Hey folks, so we are almost closing on BGP. The last topic which we'll discuss today is attributes. Um, yeah, let me just go to my whiteboard to clear up a few things. There are two types of flows, right, in a router. One is your route flow, and the other one is your traffic flow, right? This is very important. So it's like, so you have your route flow here, right? So this is your route flow, and then you have your traffic flow. Right, these both are different. The route flow is basically your control plane, whereas traffic flow is your data plane, right? Which means, let's say you have your router R1 here, and here you have R2, right? This way they are connected. Yeah, so the route flow, right, the routes which are going to be sent from R1 to R2, right, they are going to be sent in this direction, right? The routes are basically going to go in this direction, whereas once R2 receives those routes, right, it is going to use to send packets, right, to the remote routes, right, and the packets are basically going to travel in the opposite direction. So there's basically going to travel in this direction, right? So you need to always remember that the route flow and the traffic flow, they are always in the opposite direction, right? So where does our attributes come in, right? The attributes, they are associated with the route flow, right? The attributes which we'll be talking today, like the weight, the AS path, the local preference, the med values, all of these, right, they are associated with the with this one, the route flow or the control plane, basically, right? They are sent along with the routing updates, and they basically use it to make the best path decisions, right? So BGP is really good in that sorts. It provides amazing flexibility when it comes to path manipulation, right? What is path manipulation? Right, just trying to engineer the best path or the preferred path, right, for a particular packet to traverse, right, between two routers, right? So path manipulation can be done in BGP by using mainly four different types of metrics, right, which we'll be covering today, right? The first one we'll be talking is the local preference, right? Local preference, and then we will have weight. We will talk about weight, and then we'll talk about med values, and the last one is we will talk about AS path, right, which I think we have already touched upon little, but we will talk again, right? So these are the four things which we will concentrate on, right? So BGP attributes, in order to take advantage of BGP, always you need to always control the path. Letting BGP select the best path is like the worst thing that you can do, right? Make sure you understand that there is a difference between what you can do technically versus what is like allowed to be done based on the contracts between the two autonomous systems, right? Now going back to my let's say, right, if you look at this one, um, this is going to be my topology for this discussion as well. And yeah, so what we'll do now is we will start learning about each of these attributes one after the other. Before that, I actually want to kind of like go and clear out a little bit here, because I think in my earlier sections we were talking about configurations, so I have some configuration related configs. So what we'll do is let's clear that out, which means I will have to redo my R1, R2 and R3. So hold on for a couple of minutes while I do that, and then we will start with the first attribute, which is the local preference, right? So coming to my R1, let me do this, right? What do I have to do? So conf t, and I just need to remove the existing router BGP 65001, right? And I need to put my new BGP, the old one which I used to have. Like I'm no more using the configurations. I'm basically using the normal BGP configuration in my AS1000, right? The topology is still the same. This is the topology, right? I'm just redoing some of the things which I kind of broke in the previous video for studying about configurations, right? So we will do network 1.0.0 here, network 11.0. The mask is going to be 255.0, and neighbor, right? The neighbors is important. The neighbor is going to be 10.2.2.2, right? Remote AS is going to be 1000 because it is iBGP, right? And do you remember the rest of the commands we used to do? We used to do update source, right? Loop back 10. We need to do next stop self because it is iBGP, right? Next stop self is done, and then the last one is let's also form the eBGP neighborships with R4 and R7, right? So for that I have to use the neighbor command, but I need to do 192.1.14.4 if I'm not wrong, right? The remote AS will be 400. I'm doing this again so that it kind of becomes more handy, and seeing it many times you guys get a hang of it, right? So remote AS for the other one R7, it's going to be 700, right? There you go. So we have done this piece. Let's go to R2 and fix that as well. So what I'm going to do here is enable configure, right, conf t, and sorry, no router BGP 65002, I believe, right? Let's clear the screen a bit. So it's going to be router BGP 1000, okay? And what else? The two networks is going to be network 2.0.0. The other one is 22. Mask is 255.0. And I'm going to use like the peer group kind of configuration here because it kind of simplifies the configuration a bit. So this is how you do it. You create a peer group, like it's like a template. It's like creating a template, right? And then you can use this template for defining your neighbor. So I'm going to create a template called iBGP. The peer group name is iBGP. Remote AS for this is going to be obviously, sorry, neighbor iBGP. The remote AS is always going to be 1000, right? Because you see from the diagram on my R2 I have two neighbors, right? One is R1 and one is R3. So instead of manually doing it for two separate neighbors separately, I can reuse this template twice, right? Kind of reducing the configurations. It's an interesting way to do this, right? So the next piece is what are those commands, right? iBGP, you gotta do this next stop, if I'm not wrong. Next stop self, you also need to do what is this update source, right? Update source loop back 10. What else? Update source next stop self, and we are going to go back and do the route reflector here, right, like we did in the earlier section. So it's going to be iBGP, and then you have the route reflector, right, client configured, right? So now once you have finished configuring your BGP peer group, what I can do is I can directly use neighbor 10.1.1.1, and I can basically call the peer group which I just now defined, right, this way, right? So you see the advantage of this. You can reuse the peer group again for 3 as well. See, there you go. So I have finished the neighborship in just a couple of commands by using the peer group which I had defined here above, right? Let's go and do this on R3 now. In R3 I need to again do the same thing. No router BGP, and I believe it's 65003, right? Router BGP 1000. And what do we do here? The two networks is going to be 3.0.0. The other one is 33.33.33.0. Mask is going to be 255.0. What else? The neighbor commands are important. Neighbor 192.1.36.6, and remote is 600, right, because that's R6. And the other one is 37.7, and it's going to be 700. That's for R7. eBGP neighborships, right? These two guys. What else? So you also need to form the neighborship with the R2, that is 10.2.2. This is iBGP basically. The remote AS clearly is going to be 1000. And you got to do those two commands which I need to do. Mainly one is the next stop self, right? So if you're doing this regularly, you get a hang of this. It's pretty simple, right? The other one is your update source loop back 10. I think we are good, if I'm not wrong. Should be good, right? Clear this a bit. Show IPBGP. Yeah, I think it's good. Looks good. Mm, yep, great. So what do we do now? Local preference is my first attribute which we'll be talking about, right? So for local preference allows you to control the outbound traffic leaving your AS. If you have multiple exits from your autonomous system, right? So it will let you choose the best exit point, right? So local preference stays within the AS. It is local to the AS. It is just a number, defaults to a in a Cisco router. It normally takes a default value of 100. Higher the better, obviously. Local preference you need to have as higher as possible, right? So we will look at an example here to understand more about this, right? So uh, yeah, so I have this topology here. Let me move on to my whiteboard screen. So in my topology, what I'm trying to do here is you have the AS1000. It wants to use a policy to kind of use the link R1 and R7 as the preferred output link, right? So let me highlight this, right? So you see this link over here, R1 to R7, right? So what I want to do is for every single route, right, or where every single packet is leaving the AS1000, right, when it is leaving to probably reach 400, 700 and 600, whenever it's leaving, every packet when it is leaving 1000 and it is coming to one of these ASs, I want to always use this link, which is R1 R7 link, right? I don't want any other link to be used, right? So when I want to do such kind of a path manipulation right now, and to do this we are going to basically use local preference, because like I said, it allows you to control the outbound traffic, right? Outbound traffic is basically traffic which is destined to go outside to some remote routes, right? So the remote routes would have been, so like I already told earlier, the route flow is completely opposite to the traffic flow, right? So we want the traffic flow to be in this direction. We want the traffic flow in this direction, which means the route flow is always in the opposite direction, right? So I need to somehow make this particular direction as the most preferred, the routes which are learned along this direction to be the most preferred ones. Only then the traffic will actually use this particular direction, right? So that is why I initially took a couple of minutes to talk about the the concept about the route flow and the traffic flow, right? So from this diagram you understand what we have to make. Our objective is basically to make R1 and R7 like the preferred path to learn the routes, right? Mainly from R7, right? All the routes from your R7, they have to be learned along R1 R7 and not along any other direction. For example, this one I don't want to be learned along this. I want it to be learned exactly between R1 or along the link R1 and R7, right? So once I do that, now like I said, local preference is just a number. So this number will be tagged, right, or will be tagged along its number, right? The default value is 100. The default value is 100. So which means any route which is learned, let's probably use a different one here. So when a route is learned along this direction, which is R1 R7, right, what we'll try to do is we will make sure that the local preference value is higher, right? Let's say we'll make it 150 here, right? So what happens is when the same route is learned along another direction, which let's say here, the default value of local preference will be 100, right? Default value is always 100. Now what happens, this route which was learnt here will be sent here to the route reflector. This also will be sent, but like I said, the at any point of time, right, the higher the local preference, better it is, right? So as a result, on the route reflector it will always select this route, right, which we learnt along this direction. Why? Because it is having a higher local preference, which is 150, right? And that route will actually be used now, and obviously because it's a route reflector, it will send that route along this direction as well. And finally, even on R3, right, if it has to send a packet to R7, it will not send it along this. Instead it will send along this direction, right? It will send along the best path, which is basically your path here over here, which we really want it to take, right? So that is exactly what we are trying to do, right? Let me just clear this out, right? So what we are trying to do is we are basically trying to make sure that we basically take this path, right, whenever whenever the traffic from the AS 1000 leaves the AS, right? So how do we do that? Is by using the local preference. So we go to my router R1, right? Let me clear the screen a bit here. And we go to router R1 and we create a route map, right? Create a very simple route map. Let's call this probably set. What are we setting? Setting set attribute, right? Let's call this set attribute, and set local preference value of 150. So we are explicitly setting it to be 150. So and then we go inside router BGP, right, 1000, and we say neighbor 192, basically my R7, right, 192.1.17.7, right? For this particular neighbor, we say route map, we attach the route map which we just now created here, over here. In which direction? In direction, because like I said, the route flow is always in the opposite direction of the traffic flow, right? So we're basically, what we're trying to do here is every single route which is learnt along R1 and R7 link, right, along this particular link here, we are basically attaching the route, or basically we are making the local preference value to be 150 or attribute to be 150. So now, because we did this, what we can do is we can clear right? So we can clear iBGP and star and soft, right? Once I did this, I can now do show iBGP, and you'll be able to see for my R7 network, right, what is the preferred path, right? For my, on my R1, you can see the preferred path is basically my R1 R7 link, right? It is the next stop is R7 directly here, and you can see the local preference value 150 which we have provided has actually gone there. Now you can see this on R2 as well, right? Let me clear this. Do show iBGP, right? You can see for R7 it is actually taking my it is going via R1, right? It is even on R2 it is taking this particular path, it's going via R1, right? On R3, let's see on R3 what has happened on R3. You can see here, or even on R3, right, it is it has multiple paths, right, actually, but the preferred path is still my R1 because of this local preference value, right? Because of the local preference value, out of all these three paths, it is preferring this one, right? And the packet basically goes to R1, and from there it goes to R7. So we kind of forced the routing protocol or BGP to always use the R1 R7 link for all the outbound traffic, right? So all the and because local preference attribute was kind of sent to every single router inside your AS, so now every single router inside your AS is able to use that particular path, or is basically considers R1 R7 link to be the preferred path for outbound traffic, right? Great. So now yeah, so that was mainly the use of the local preference attribute. Okay, we'll go to the next one. So we talked about the outbound traffic. What about the inbound traffic? So that should be a next question, right? So if I go to my screen here, and what I mean by the inbound traffic is that if I probably, let's take a different color here, right? So maybe a different one, right? So when I say inbound traffic, I'm actually talking about so let's say this path, right? So I want all the inbound traffic to take the link R3 and R7, right? So outbound traffic was the traffic destined outside the AS to some remote routes, right, to some remote networks, whereas inbound traffic is basically the traffic destined to my own routers inside AS 1000, right, either to one R1 network or R2 networks or R3 networks, right? So what we want to do is we want to control even that. We want to control on which link the traffic is coming inside, right? And that's where we use the second attribute, which is the MET, multi-exit discriminator, right? It allows you to control the inbound traffic. Inbound traffic will be for routes that are advertised by by the AS, right? uh, med is basically like a metric, right? It is like the cost, and lower the better, right? It's completely opposite to the local preference. In local preference, higher the better the value, but in case of med it is lower the better. And the default value of med is 0. The default is, by default it is set to 0. So any route, when it comes inside, right, any for any route, right, on R7, if you go and see show IP BGP, you'll see that the default value of met is going to be 0. So this becomes little tricky because obviously you can't make it negative. So in order to select a particular router as the preferred router, like in this scenario we want R3 to be the preferred router, right, for all the inbound traffic, you have to configure a higher med value on another router, in this case R1, right? So we kind of go and poison the other router to have a higher med value. That way your R3 will be the preferred router always, right? So let's look at that. So let's take an example. In this case, like I said, I would like to use the R3 R7 link, right? Basically this link over here for all the inbound traffic coming towards the networks advertised by my AS, right? So what I do is we go to the non-preferred router and we do the configuration. We don't do it on the preferred router, like I said earlier. We go and do it on the non-preferred router, which is my R1, right? So that's what we're going to do. So we go to my R1. Let's go to my R1, right? So let's actually see this before we even do this. Let me show this on R7. How does it look, right? Let me clear the screen. So like I said, inbound traffic, right? So for inbound traffic, that is why I'm showing you what is happening on R7 here. So on R7, if I do show iBGP, what you see here is that currently to reach networks, for example, 1, right, the preferred path is, what is the preferred path? It is 192.1.17.1. So it's basically the R1 R7 link, right? This is the link for reaching the 1 network. For reaching the 2 network, again the preferred link is R1 and R2. But for the 3 network, it is already the link which we want, the R3 R7. But nevertheless, what we want to do right now is on R7, right? We want to make this change such that to reach the 1 network, it should always choose this 37.3, which is the R3 R7 link, right? Even for the 2 network, it should choose this, the R3 R7 link. We want to force my R7 to do that. So to do that, we have to change the med value on the non-preferred router, which is my R1, right? Let me clear the screen a bit. So what I'll do here is create another route map. So we create route dash map and set what med value. So we're gonna put that route map, set metric, right? You say set metric. What metric? We're gonna create some huge value, right? Probably 111, right? The default is 0, so I can choose any value between 0 and 111, right? And once we are done with the route map, what we'll do is we'll go to the router. We'll go to BGP router BGP, right? And we will go to 1000. The neighbor is going to be 192.1.17.7. Do you agree? Right, because I'm forming neighborship. I'm basically trying to poison my med value for all the routes which are learned along the R1 R7 link, right? So I'm going to do that, and this is going to be my route map. Sorry. And for all the routes basically which are being advertised by my AS in the outward direction, right? So here because we are talking about the inbound traffic, the route flow is in the opposite direction. Always remember that, right? We are talking about the inbound traffic, the traffic which is coming in, so route will be always in the opposite direction. So in this case, because I'm doing it on R1, I'm doing out, right? So once I do this, right, let me go clear IP BGP star soft. Okay, now if I go back to my R7, you will start seeing the differences, right? Let's see. Yep, you can see the changes. So here earlier we had, for the 1 network, this was the preferred path, right? You see a arrow mark here, right? So you see that greater than sign. So it was basically taking my R1 R7 link. But now because I made the changes, I poisoned the med values on my R1 router, so it is starting to use my R3 R7 link. Even here you can see R3 R7 link, R3 R7 link, right? So that is how you can control the inbound traffic, right? So yeah, so that was interesting, right? Now the next attribute which we are going to look into is weight. Weight is another interesting attribute which we want to look into, right? So what is the main use of this? So let's go back to the diagram, right? Let's probably go back to the diagram here, right? So what we have achieved now is that outbound traffic we are making use of the R1 R7 link. For the inbound traffic we are using the R3 and R7 link, right? Which is all good, right? uh, but if you observe, what we have done is, let's concentrate only on the outbound traffic, right? Because weight is concerned only with the outbound traffic. I'm not concerned with the inbound traffic, so I can just probably remove this path, right? So only the outbound traffic. So what we did, like I said, in local preference, using the local preference attribute, we did for all the outbound traffic from the whole of AS, right, to all the remote routes, we made it go through this R1 R7 link for the whole of AS, right? But what if we want to control the uh, outbound traffic, or we want to do the path magnification, right? Not for the whole AS but for a specific router, right? We want to do for a specific router, which means let's say I want to still use my R1 and R7 link for my outbound traffic from all the routers, for say for R1 and R2, but for my R3, which is here, right? For my R3 router, I want to use this particular link as my outbound, outbound, for my outbound traffic. I want to use this link, right? So for R1, it goes this way. For R2 also it goes this way. But for R3, I really want to use the R3 R7 link, right? I don't want it to be sent all the way across to R1. So that is my use case, right? So you use weight, right, when we want to control the outbound traffic, similar to local pref, but when we want to do path manipulation for a specific router and not the whole AS, like, because local preference, when we did local preference, the attribute was propagated to all the routers in the AS, right? As a result, all the routers started behaving the same way, wherein the preferred route, all of them started using the preferred route as R1 R7. But weight is an attribute which is not propagated to the other routers, right? It allows I mean, it is basically going to be local to the router wherever you configure it. Higher the better value, right? Default weight also is again 0. Higher the better, right? So what we will do now is that we will, on the R3 router, we will say that any route which is learnt, right? This is the traffic flow. We are talking about outbound. So the route flow is obviously in the inbound, in this direction, obviously. So we are basically telling on R1, we are basically telling R1 that any route which you learn from R7, attach a weight of say 11, right? So what happens now is that the same route will be learned in this direction as well, right? Which means the route will come here on R2, right? And the route will from R2 come to R3 as well. So on my R3, I'll have two routes to reach my R7, right? One of them will have a local preference of 150, and the other one will have a default local preference of 100. But this one will have a higher weight, right? It will have a weight of 11, whereas this one will have a weight of 0, right? Now between local preference and weight takes a priority, and as a result of that, R3 will always use this particular path, or it will use the R3 R7 link to send the traffic out, right? So we look how this works in action. We'll configure this and we will play around with this, right? So what we will do now is we will go to my R3. We clear this a bit, sorry, R3, and we will say show IP BGP. Okay, when you see this, what do you see? You see that R7 or basically the 7 network is reachable via R1, right? Is reachable via R1, which is not something which I want. On my R3, I want my 7 network to be reachable via this particular network, and we'll see how we can achieve that. Right now it is taking this. Why? Because the metric here, or basically the local preference value, is 150, higher than the default values which are here, which is 100 and 100, right? So this is taking the R1 route, right, which means it is going from R3 to R1 and then to R7, right? It is using the preferred path which we defined earlier using the local preference, right? Now we will change this by creating a route map. Let's go here. Let's go map route map of what? Let's say set weight of what? 11, right? You go and do router BGP 1000, and the neighbor command is 192.1.37, right, because that's your neighbor. 37.7, and the route map is gonna be what is my route map? Gonna be the set weight, and for all the route flow is always opposite to traffic flow, always remember that. So we are basically trying to put the weight of 11 for all the routes which are learned along the R3 R7 link, right, coming inside R3. So it's going to be inward direction. Great. Let me do a clear here. Do clear IP, BGP, and star and soft. Make sense? Right? What do we do next? Now if you go to my earlier this thing, right, where we had this whole thing. So if I do show IP BGP, you'll see the difference. Is there a difference? You can see here for the 7 network, the preferred path has changed to my R3 R7 link, right? Because though the value of local preference is 150 here, and for our path it is 100, but still it is taking it because it has a weight of 11. So weight always takes precedence when more than your local preference, right? So if I do a trace here, right, if I do a trace, let me clear the screen, right, let me do a trace to where my 7 R7, and if I do a source from source 3.3.3, you will see that it will directly go to R7 and it will not go to R1, right? Give it a second, it should come up. While that is coming up, let me actually show you what is happening on the rest of the routers. The rest of the routers will still take show IP BGP. The rest of the routers, which is R2, say, it will still take what? My R1 R7 link, right? Because this is the one with the higher local preference, right? The weight value has not propagated to my other routers. The weight value will always remain local. See here on R2, I don't have that weight, right? Has this trace route completed? Yes. So you can see the trace route here for R7, it is directly taking the R3 R7 link, right? It directly took this link and instead did not go. So weight is an attribute which you use in a similar case as your local preference, right, for your outbound traffic, that is. But when you want to kind of like manipulate the outbound traffic only for a specific router and not for the whole of the AS, right? If you want to do it for the whole of the AS, you want to make the whole AS take a preferred path, then you use local preference. But if you want only one specific router to take a preferred path, then you go for your weight, right? Now if you look at the outbound traffic, we used weight and local preference to manipulate it, right, and both were applied on the incoming routes. For the inbound traffic, we used the med, right, and we applied that on the outgoing routes, right? That was what we did. But in both the scenarios, what we see is, if I go back to my whiteboard, right, in both these scenarios, let me actually clear this up. This looks a little messy. Let me clear this up, right? Yeah. So if I pull my image back again, right, what we did is we for my outbound traffic, inbound traffic, we use now we have studied about 3 attributes: weight, local preference, and med, right? So you see, your weight and the local preference was only active, or was only applicable only inside your AS, right? Whereas the med value, it was applicable for the adjoining ASs, right? The med value, you basically configured. In my case, I configured it on R1 for all the routes which are coming in this direction, and we poisoned the med value so that all the routes basically now prefer this particular path, right? But it was only applicable in your adjoining ASs, so which means you can do that on between 1000 and 500, 600, 700, 400, but you can't do it probably, you can't control it for another AS which is probably behind this 700 and stuff like that, right? But what I mean to say is, in both the cases, we were either able to control the traffic, or it was only applicable, the attributes which we studied till now were applicable only either inside the AS, local to the AS, or the very next AS that's adjoining one. But the next attribute, AS path, right, it has significance in the whole BGP domain, right? Which means, even if you have an AS which is beside your 7000, right, the AS numbers or the AS values which you learn, right, in which it will be available, or it will be applicable throughout the whole of AS, throughout the whole of BGP domain, in fact, right? So AS path as an attribute allows you to control, or ability to control, the outgoing as well as the incoming traffic, right? So that's very interesting. It will not just the the earlier attributes, it was either talking about the outgoing traffic or the incoming traffic, but in AS path you can control both, right? The shorter AS path is always preferred. So once you prepend the AS path, it will be propagated throughout the BGP domain and will affect traffic not only in your AS but also the entire BGP domain, right? So the idea here is very simple. What we'll do is, if you want to make a particular path as not favorable, right, we basically append, or we basically poison that AS path by attaching or appending it by another AS path number. That's it. And you know that any router, anytime it is choosing the AS, it will always choose based on the shortest AS path, right? The other part which I want to cover here is the priority. Like, if you have a network where they're using all these attributes, then the first preference goes for weight. The second preference would go for the local preference. The second priority is the local preference. Then comes AS path, right? And the last one is your med value, right? So this is 1, 2, 3, and 4. So this is how your preference or priority plays out, right? If you have two routes with the same weight, then local preference will be selected. Same local preference, then AS path. So it goes that way. Okay, great. So to study this example, or to study about AS path, what we are going to do is, whatever we did earlier, we are going to kind of do the same thing using AS path, which means what I will do is clear this out a bit. Right, so what I'm trying to do here is, I will use my R1 R7 for my outbound over here, right? This is going to be my outbound, like earlier. R1 and R7 is going to be outbound, whereas R3 R7 will be for my inbound traffic, right? But we are going to do this not using the earlier attributes, but completely or solely using my AS path, right? So that's going to be fun. So what we'll do first is, let's remove the old attributes which we use. So when we go to R1, and we will basically see what do we have here. So we'll say show run section router, right? You can see that we have your right, we have these two route maps which we'll have to remove, right? Let's do that. Let's go here. Let's take this, and the other one is this one. There you go, we removed it. Okay, on we did that on R1. Let's do it on R3 as well, because we have done something here. Show run section router, right? We have a route map here. Let's remove this as well. This was for the weight which we did, right? So we will go and remove that. Let's take this, right? We have removed it now completely, right? So I can probably clear eBGP star soft, right? Let me do this on R1 as well. Great. So now for the outbound traffic, right? We are interested in all the traffic taking the R1 R7 link. So what we'll do is we'll start by going to R1 and creating a route map. Route map set AS path. Set AS path will be my attribute. We will prepend this particular, all the routes which are learned along this particular link. We will prepend. Oh, so my bad. So what we want to do is we want to, let me remove this. Sorry, my bad. This is a mistake. What we want to do is, like I said, we want to use my R1 R7 link for outbound traffic, which means I have to go and poison my R3 router, right? Because that is the other way where the routes are going to be learned. So we're going to do this one here. We say route map, I don't know, we'll say set AS, right? Set AS path is going to be prepend 700, right? We are adding an extra AS path, and the router BGP is going to be 1000, right? And we go to neighbor 192.1.37, my bad, 37.7, and route map is what is route map? The set AS, and for all the routes which are learned in the inward direction, right? The routes always flow in the opposite direction of the traffic. So all the routes which are going to be learned along the R3 R7 link, we are poisoning it. We are adding an extra adding an extra AS path. So once we have done that, you can see what will happen is on my R3, if I do show IPBGP, you will be able to see okay, it's still not. I'll have to probably wait for a minute. Nope, still not up. Probably do a clear, which I do always. Yep, I think now it's up. So you can see for the 7 network, what is the preferred one? It is taking the R1 R7 link, right? It is taking the R1, it is going to R1, and you can see here for the R3 R7 link, it is actually prepending the AS700, right? So between these two links, it ended up selecting the R1 because because you see here this one, okay, it's still showing 150 here. Did I remove this 150? Ideally it shouldn't have 150, it should have 100, right? The reason is because the local preference value, I have actually removed it here on my R1. Probably I'll have to clear it here as well. Clear IPBGP. Give me a second, let's clear this. Show IPBGP on here. Okay. Show run section router BGP. Clear IPBGP star and soft. Yeah, okay, now it's all clear. Now it's all 100. So it takes some time to clear and all of that, right? So let me hit the refresh here. Okay, now you can see for this R7 network, right, all the 3 routes have the default local preference value, which is 100, and it is we have made R3 prefer the R1 R7 link, right, for outbound traffic by simply poisoning the AS, right? For the other path, we have added an extra 700 here. You can see there are two 700s, right? And this is something which we added just now by manipulating the AS path, right? For the link which we want, you can see, that route, it doesn't have that poisoned AS path, right? So that's why it's taking this particular, preferring that particular link for the outbound traffic, right? So that's the fundamental. The idea is very simple, right? You want the link to be preferred for the other link, basically, or the other router. Make sure you add the AS path. So all the routes which are learned along R3, right, you will basically have that AS path prepended, and as a result, you will always prefer the R1 link, right? Now for the inbound traffic, we can do the same thing. We want the R1 or the R3, R7 link for the inbound traffic. So we will obviously go and poison the other side, right? So we will now probably go and do this on R1. We will have to poison the other side. So let's go and do this. Let's clear the screen. So we will say configure route map, right? Set AS path, set AS path attribute. You're gonna prepend what? You're gonna prepend probably, let's say 1000, right? And now it doesn't matter what the value is, because it just need to have an extra value up there. So yeah, so we are basically telling all the routes when they are leaving the R1 router, because it's inbound traffic, right? So the traffic flow will be outflow, or going in the outside direction. So we are basically saying, let's say 192.1.17.7. so whenever the routes are going outside R1 towards R7, right, we are basically telling prepend is set AS path and the outside direction, right? So we are basically prepending the AS number 1000. If I do clear iBGP star and soft, right? Now if you go to my R7, right, if you go to my R7, you will see that yeah, on my R7 show IP BGP, if you do this, you will see for this network, for the one network, it is preferring the R3 R7 link. For the 2 network, it is still preferring R3 R7. For the 3 network also, it is preferring the R3 R7 link, right? And you can see here, between you can see, look at, just if you concentrate only on the R1 network, right, on R7 you can see that there is a prepended AS, right? AS 1000 was added when the route was learned via R1. So that is why it is preferring this particular route, because it is the shortest path with only 1000, right? So that is how you can manipulate your traffic, both the inbound and outbound traffic, using your AS path, right? So to summarize, what we learned is, you want to manipulate your outbound traffic, you can either use you can use your local preference, right, or you can use your weight, right? But weight you use only if you want to kind of manipulate only on one router, right? Or not just one, I mean, you want to do it on specific routers. But if you want to manipulate the outbound traffic for the whole of AS, then you use local preference. Now similarly, for you want to manipulate inbound traffic, you use MEDS, right? And AS path is actually an attribute which you can use for manipulating either your outbound traffic or inbound traffic. The idea is very simple. You go and poison the other router with the higher AS path, so that won't be preferred and the lower AS path will be preferred, right? So that's it. That's the whole section on BGP. Hope you liked it. I think we have pretty much covered every single topic which I have mentioned here. Hope you guys liked it. Do look into the other sections, the other videos part of the series, to understand the whole BGP concept. All right, thank you.